Compared to the other planets in our solar system, Earth has the best weather. Even if you may need an umbrella from time to time, deadly sulphuric acid precipitation is not a concern here. Hello, everyone! In this video, we will let you know about the most extreme weather in our solar system. But before we get started, do not forget to like and subscribe to my channel. Hit the bell icon to stay up to date with the latest videos. So let's take a look at 7 of the most extreme weather conditions on other planets in our solar system. Mercury's dramatic temperature swing. Indeed, Mercury's harsh physical circumstances are due in part to the fact that it has essentially no atmosphere. It's hardly surprising the closest planet to the Sun can also get very hot, but because it has no atmosphere to trap the heat, it experiences extreme temperature swings. Mercury has almost no atmosphere and an extremely shallow axial tilt. This eliminates the cyclical nature of the weather. It takes it around 3 days every 2 years to go around, making its rotation extremely sluggish. If a human were to land on Mercury, they would either instantly catch fire or freeze to death. Due to the lack of a substantial atmosphere, Mercury has essentially no weather in the form of storms, clouds, rain, or wind. Because of its proximity to the Sun, the surface temperature of Mercury can reach 427 degrees Celsius during the day and drop to minus 172 degrees Celsius at night. Raining sulphuric acid on Venus. Venus is a literal hellscape with searing heat, oppressive pressure, and sulphuric acid rain. Venus can reach much higher temperatures than Mercury because its atmosphere is so thick and mostly made of carbon dioxide. The average annual high is around 900 degrees Fahrenheit, 480 degrees Celsius. On Venus, the atmospheric pressure is roughly 90 times that of Earth's sea level. A diver would have to plunge 1,000 meters below the surface to experience the same pressure here on land. Venus's rain is nearly pure sulphuric acid, making it a highly caustic substance. Sulphuric acid has the potential to burn skin severely and quickly erode clothing. Rain falls on Venus, but the surface temperature is so high that it evaporates before it can reach the ground. Water vapor in the air combines with sulphuric acid and can cause tremendous explosions. Venus is just slightly smaller than Earth, but its atmosphere completes a rotation in about 4 hours. On Earth, the equivalent process takes around 243 days. Venus has snow, despite its scorching temperatures. No, this isn't typical snow. Metals that evaporated in the air left behind this basalt frost. Massive amounts of snow on Mars. There is a lot of research being done on Mars right now because some people think it could have supported life in the past and might hold clues to the beginning of life on Earth. Since water was once flowing there, the air must have had the right conditions to keep it there. Now that the ground is dry, massive dust cyclones can rip the landscape to shreds. Even though Mars has strange weather, nobody knows why it doesn't have an atmosphere. Polar regions are frozen over, and there is heavy snowfall. Snow on Earth is formed of frozen water, whereas on Mars, it is dry ice, or carbon dioxide that has been frozen solid. In 2018, a significant dust storm obscured Mars. These storms, called haboobs on Earth, occur every few years on Mars, but this one was exceptionally enormous. According to NASA, the Sun heats the planet's atmosphere, raising dust off the ground. Scientists don't know how they grow so enormous. Opens in a new tab. They hinder solar-powered surface rovers. Dust devils, mini tornadoes, form and move across Mars. Earth too experiences this occurrence. When the ground heats up, nearby air rises and forms dust devils. As air rises, it can collide with cooler air higher up, rotating the column. Dust devils are visible because they kick up dirt. They're visible from orbit. The Mars Reconnaissance Orbiter found a 2,600-foot-tall, 98-foot-wide dust devil on Mars in 2012. Gigantic storms that occurred on Jupiter eons ago. Jupiter is famously known for the enormous storms that it can produce. One of its most well-known storms, though, is the Great Red Spot, which has been wreaking havoc on the Earth for somewhere in the neighborhood of 400 years. The storm has the capacity to engulf 2 or 3 planets that are roughly the size of Earth. This storm is so enormous that it could easily accommodate 3 Earths inside of it. Another location, known as the Oval BA, was found around 7 years ago and is now moving at the same rapid pace as its larger cousin. It even gives the impression of getting bigger over time. Jet streams are responsible for giving Jupiter its distinctive struct appearance. Although the number of jet streams on Earth can vary, in most cases, there are just 1 or 2 in each hemisphere. At least 30 of them rip over the surface of Jupiter in opposing directions, reaching speeds of about 300 miles per hour, 480 kilometers per hour, 300 miles per hour. The presence of the GRS and its current location can be attributed to the interaction of 2 of these jet streams, because the temperature in that region of the atmosphere is minus 140 degrees Celsius, minus 220 degrees Fahrenheit. The clouds that seem like stripes are made of frozen ammonia. In the early part of this year, it was found out that Jupiter's atmosphere is capable of producing diamonds. Saturn's lightning. Lightning has been observed and heard on Saturn, which is quite remarkable. Scientists estimate that some bolts are 10,000 times more powerful than those on Earth, because they are intense enough to be visible during the day by NASA's Cassini. Opens a new TAB mission, which orbited Saturn from 2004 to 2017. Opens a new tab. Cassini was also able to hear the storms discharging in the atmosphere by monitoring radio signals from the planet. Storms on Saturn can grow to be more than 190,000 miles, 300,000 kilometers, wide and circle almost the whole planet. The gas giant's North Pole has a strange permanent hexagon that goes deep into the planet's interior. Saturn, like Jupiter, has a main hydrogen atmosphere. A bullet can travel about as fast as the wind, which can reach speeds of up to 1609 kilometers per hour, 1,000 F. In 1996, during Tropical Cyclone Cynthia, the highest hurricane wind speed ever recorded on Earth was 408 kilometers per hour, 253 miles per hour. The storm near Saturn's North Pole is the coolest in the solar system. Unlike other extreme weather systems, its shape is a hexagon rather than a circle or sphere. An image composite produced last month provides the best view of this storm to date. At almost exactly half the diameter of Earth, at 8,600 miles, 13,800 kilometers. Per side, the hexagon has 6 equal sides. Despite the thin and frigid atmosphere, there is enough heat near the surface to cause severe storms. A storm 10,000 kilometers wide is brewing in the northern hemisphere. The equivalent on Earth would be a trip from Los Angeles to Beijing in a direct easterly course. The carbon in the atmosphere near Saturn's surface can be compressed into graphite. The lead from pencils does indeed float around Saturn. Diamonds are formed from carbon, which is much closer to the center of the Earth. The diamonds on Saturn would pierce a human being like thousands of tiny arrows. Uranus, the coldest planet in the solar system. Temperatures on Uranus reach 224 degrees Celsius, minus 371 degrees Fahrenheit, making it the coldest planet in the solar system. Uranus is extremely peculiar in that it lies on its side, with its north pole facing the sun. A large collision may have caused this, as its magnetic field is not perpendicular to its poles. While its weather system and massive hurricanes are invisible without infrared equipment, Uranus is actually quite active and worth exploring. Diamonds are also falling to the surface of Uranus, just like they are on Jupiter. Pluto. Pluto's very eccentric orbit causes its temperature to fluctuate by enormous amounts. At its aphelion, when Pluto is furthest from the Sun, the planet freezes solid. As it approaches the Sun, the gas expands and creates a gaseous atmosphere, making it look and behave more like a comet than a planet. According to Neil deGrasse Tyson, if you move Pluto to where Earth is right now, the Sun's heat would melt the ice on its surface, and it would grow a tail. That's not planet behavior, that's for sure. Our solar system has tremendous weather. Understanding these systems can help us understand how some planets develop and potentially suggest life on other planets. When it comes to actually visiting some of these worlds, home is best. Thank you for watching. Stay tuned for more upcoming videos.